with RSA Solutions, and I really do want to thank you for joining us today. Also, panelist and software presenter will be Jonathan Saucier of WebCAD Smart Solutions. I'll introduce Jonathan and give him an opportunity to talk a little bit about his company and technologies a little bit later in the webcast. In today's webcast, we're going to spend a few minutes to talk about the fourth industrial revolution that we're now part of and where technology has gone. We're going to focus in more deeply on MES technology, manufacturing execution systems. Again, I'll introduce our guest presenter, and then we'll have a software presentation followed by a Q&A session. Industrial revolutions. I want to point out a few things. I think that we all understand that we're in an interesting day and time. Technology is moving quickly. The internet has changed the way that we work, we act, we think in so many ways. In roughly the end of the 18th century was when we termed it to be the very first industrial revolution. Actually, in 1784 was the first mechanical weaving loom, and so that was a tremendous advancement to industry to be moving from very, very manual processes to being able to have mechanical devices do very incredible things. It wasn't for about another 100 years that we saw the second industrial revolution, and we know about those things still today, but the first occurred in Cincinnati in roughly 1870 in a meat slaughterhouse to where production lines were the next industrial revolution. In a much shorter amount of time, in only 70 years, we started to see the first programmable logic or PLC controls, and that's allowed us to begin to have computers talking to computers, and that revolutionized a lot of things. In even a shorter period of time, we have our fourth industrial revolution, and we're going to focus in on it today. If you see the trend in timing, 100 years between the first and second, 70 years between the second and third, and only 40 years between the third and the fourth. Certainly, technology is moving faster. The time between these is shrinking, and it's shrinking at the pace of technological advancement. That puts us in a unique position that we need to fully understand that what Industry 4.0 is, and also how that can have effect upon us. So when we think about Industry 4.0, certainly we have to understand that this fourth industrial revolution is very much impacted by the Internet of Things and the Internet of Services. It is the communication between bots, between employees, between machines, and all of the devices that we're using. All of us today probably have examples of more devices connected to the internet than ever before, whether it's home appliances, automated thermostats, or even our devices that we use for communication. There are 6 design principles that have to do with Industry 4.0. Interoperability is the very first one. In case you don't have a nice simple definition of that, is it's all things working together so that there is communication between all things. The second is virtualization. We might think about that as virtual imaging. We might think about that as virtual servers, clouds, or even operating systems. And decentralization is the next, where local decisions are being able to be made real time instead of being centralized. Automated feedback or real-time capability to gain information from the office, from the shop floor, in all the aspects of manufacturing. Service orientation, to where everything is focused around the customer experience. And then finally, the final one is modularity, where not one size fits all, where it's possible to integrate new Industry 4.0 thinking even into existing factories and operations. The Internet of Things has been a great change. It's said by some that people at the age of 2 may never even learn to drive a car. Certainly we know that if you give a young person an electronic device, a computer, that they have an ability to pick up and to begin to utilize in ways that are not common for some of us who are a little bit older. You know, yesterday is behind us, to where we thought the great revolution was a computer speaking to a computer. Tomorrow is really where we need to head, but what is Industry 4.0 and how can we make that applicable for today? Most of us, we can't simply build all new factories and equip them with the latest equipment and controllers, but we can use the influence and the understanding and principles of Industry 4.0 in our future decision processes. Here are some of the examples, just a few examples of Industry 4.0 technologies. Industry 4.0 web commerce, or point of sale, is very different than how we shopped on the web in the past. It's web commerce that is highly configurable. It is fully parametric, and where sales orders can become instant production orders without manual intervention. Industry 4.0 CADCAM is real engineer-to-order CAD-CAM that can manage all aspects of production and engineering, not just simple boxes. Industry 4.0 optimization and nesting is one database driving both or nesting and optimization, as well as managing the creation and the use of reusable scrap and control. So all of that kind of thinking goes together. I want so much of our focus here today to be focused around what is MES. MES is Manufacturing Execution System. It is a control system for managing and monitoring work in progress on a factory floor. An MES system keeps track of all manufacturing information in real time, receiving up to the minute data from robots, machine monitors, and employees. I wanted to take just a moment to say, how much does it cost? Not software, but how much does it cost when assembly starts but can't finish putting something together because a part is missing or damaged? What does it cost to leave something off of the delivery truck for shipment to an end user or job site? What does it cost each time that production has to come to the office for more or corrective information? What does it cost to manually find out where something is, where a work order is on the production floor? What does it cost for all of the paperwork that must accompany work orders into the shop so that there's enough information? What does it cost to expedite part shipments or product shipments because there wasn't a way for decentralized part alerts and for quick decision making? I know that in interviewing a number of customers, these things are all very costly to businesses. Sometimes it's difficult to know how to put exact dollar values on there, but they are certainly expensive in the process. Industry 4.0 and MES is giving you the ability to get a real-time 360-degree view of your factory's operations, control, and view your entire production, eliminate physical files, and to allow your project progress in real time. With manufacturing execution systems, production and planning assistant, many things can be achieved. One of the design principles, of course, of Industry 4.0 is modularity. So you don't have to be interested in doing all of the aspects of MES to gain benefit from it. In this particular MES strategy, you will see the ability to import from CADCAM. So that would mean instead of having to replace how you're doing design, engineering, and outputting manufacturing or G-code data, you can utilize existing engineering softwares like CADCAM, Cabinet Vision, or Microvellum to be able to work with the system. So that is all things working together, the very first design principle of Industry 4.0. Being able to help and deal with the planning and organization of what will occur on the shop floor, how we are going to release to manufacturing. Being able to enhance data to create automated sortings and or routing information back to the part labels. Being able to track the progress of work orders on the shop floor, and in some cases in very incredible ways with automated machine feedback. To be able to use the design principle for decentralization to allow persons on the shop floor to be able to create automated part alerts so that quick decisions can be made for management about whether to create those things as back orders or to reintroduce them as rework orders and to have them meet up with the associated product in manufacturing. Visualization and the ability, one of the design principles was related to cyber and to being able to visualize what can happen literally on the fly. Kitting, the ability to organize items for shipment that might not be part of assembly, such as loose hardware or molding, and then to be able to track all of the items that make it onto the truck to verify that nothing is missing or not the wrong things are making their way onto the truck. I mentioned data enrichment for a moment, and I just want to focus in for a moment to say that in data enrichment, literally the ability to not only receive data from your existing CAD-CAM, but to be able to push information organized back to it so that part labels coming from it can have things such as sorting. In this example, we have a picture of a nice nested base router, and it would be very helpful for the person unloading the router to be able to understand better organization principles for the next operation. For example, edge banding. That might be, so if the edge bander received parts sorted by edge band color or thickness in a proper way, they could be more efficient at that operation. And or things such as routing as data enhancement so that it is giving a clear vision of the shop floor as to the next operations. Coming off the edge bander might be something like a horizontal bore and down insertion machine, or other parts might make their way directly to assembly. So there's an ability within the MES to help with data enrichment. Another that I mentioned earlier was automated feedback. Today, it's not obvious for you to see in the software demonstration because we don't have a real factory, but with technology such as the HOMAG Power Touch control with automated feedback, it's possible for MES systems to be receiving automated feedback as to the progress of production without human intervention. Today, I want to introduce to you a co-presenter, Jonathan Saucier of WebCab Solutions. Jonathan is going to take a few minutes to talk about his company, their vision, and to show you specifically in a real way what we're talking about that is not only Industry 4.0 thinking, but is here and now. It is real and is something that you can consider deploying for your very own factory. So Jonathan, can you hear me okay?
Yes.
Awesome. Please introduce yourself and your company.
Perfect. So first of all, I would like to also say hello. My name is Jonathan. I am from WebCab. So for start, who is WebCab? We're a team specialized in development and implementing smart solutions from the woodworking industries. We have with more than 2,700 optimized users of our softwares that we have. Innovation, customer, service loyalty, corporative, and unit are our main values and goal of the company. Our mission that we have is to bring your productivity to the next level by optimizing your day-to-day processes with proven, simple, and reliable solutions. So first of all, I will start by showing you today our production assistant, our MES software that we have. So at first, what's really important with our software is that we work with and we import data from different CADCAM software. So we do have Microvellum, WCC, Cabinet Vision software that can be imported towards that. Really easy to import any job that you want inside your project. The way the system is really devised is that you have your software jobs on the left that you have imported, and when you go inside your screen, you have your products and your accessories that's already been separated for you guys in the shop. One of the first aspects of the software when we use it is to be able to track the status of your job where it is by using scan guns or scan information barcodes to tell the aspect where you are. So if I'm using like the nesting and I want to say that I finished or started a nesting job, I can scan first to say I started my job. Automatically the system recognizes which job it is, and when I scan to finish my job, it's going to change the status of my project to say that the CNC is finished. And I can easily track the information of a project and know exactly the status of where my operation at and how much cabinet or accessories is missing to be finished with my job. A second strength that we have with our software is using the visualization. So if you have a person at the assembly that want to see more details or want to know where a part is inside of a project. So the key goal is to be able to have with the part labels barcodes and scan that part and be able to recognize exactly where that part goes inside the product that we have being drawn right here. What's really interesting with that drawing that you see on the right is that it is a 3D drawing that has been reproduced in the webcam technologies that we have here. We can hide some parts and go see more details on specific cabinet that we can have. By changing the parts on the drawing, I recognize where it is exactly inside the drawing, and I can get more detailed information of that part. Another function with the software really important is to be able to recognize when there's damaged part and know by the shop and even the office when do you have damaged parts. So to be able to just click on say on that part right there and give them a reason why the part has been damaged and be able to inform everybody in the office or the ones that we want that there is a damaged part and there's a reason why it has been damaged and be able to retake it towards the shop. So by opening our warning center, we are able to just say, okay, let me send back that part in the shop as it recognizes them to the CNC. And as we see right there, we have a yellow line that explains that for that product right there, there is some parts that's going to come back so we can be able to track it. Another important function with the system that we want to be able to know and see is when do we have parts that are ready for the assembly. So we don't want the guys at the assembly starting to work on a product without having the ensure that he has all these parts together to be able to assemble these cabinets. So easily we can give them at each part an aspect to say, okay, the part has been inspected. It can be manually or it can be scanned parts, and it changed automatically the status of each one. Other function that's really interested inside of the software is to be able to create kits of accessories or elements that need to regroup together. So often we need to do expedition of things without knowing exactly what's inside a packing. So easily with the software, we're able to do kits by just selecting our product, give them a number of kits that we want, and automatically get a label for that kit right there that we just created. So as purpose right now, I'm creating that labeling as a PDF file, but normally goes directly to a printer where you have a barcode that you can scan and see that all these information that attached to that kit is able to be shipped. Other function that we need with the software is to be able to track what has been shipped or not easily and get a report that we can have for a delivery report with all the information. So every time that you scan a product that's in the truck, the system's going to track it as it's been shipped. And you're going to have your count of product that's going to tell you what has been shipped inside the truck, or if there's some back orders that has not been scanned for the shipping. It's all real-time data that you get. Other function that can be really interesting is to know and to have a count of products or of assembly products that has been scanned or finished in one day. So easily you can have that number of counts that's being placed inside the shop that everybody knows each day how much product or how much accessory has been done inside the project. Attached to that, we can have planning information. So if I do select a day or a week of information, I can see first is the tracking of each project that's going to change the color depending of where am I inside the shop, or even with the office task that we can have. We can also have planning information to know how much goal or how much sheet did I cut on my CNC to follow our goal, and also money that's been produced in 1 week. With the planning assistance, pretty easy to use and simple tools where you can also select a job and just move it like this to change its production date. All the planning information that's related towards that is also linked and possible to be linked with a Google Calendar. So even with your project, your guys on the road can have access on their mobile of what they need to deliver or when they have to do the installation of their project without having no extra fee of licensing. So that was our part of a wrap-up of our MES software. Sean?
I want Jonathan, first of all, to thank you for introducing us to your company and also to your amazing software technology. I wanted to just point out a few things. Number one, we mentioned earlier that there were 6 basic design principles that were involved in Industry 4.0. One was interoperability. So we were, if we think about how that relates to this system, the ability to not only be able to import existing data from your current design software, but also to be able to enhance that data for even more or better information related to the part labels. The second principle was virtualization, and I don't know if it was 100% clear, but this software is literally creating from the data that it's importing a live rendering of the product. So if you scan the part label of it, you're seeing the detailed information about that part, how it's positioned within the assembly, and any associated hardware for that. So it is being created virtually. Decentralization was the next design principle. And if you noticed, Jonathan demonstrated how easy it was for an operator to be able to scan a bar code of a part and to be able to mark that part not only as damaged, but also define how or where, based on your definitions, that would happen. So decentralization of that information so that then real-time capability can be real-time information can come back. That is the 4th design principle, is real-time capability. That is not only happening with part alerts, but also with the trackings, especially if you have the HOMAG power touch control, then it would be possible for those things to even be in an automatic mode. The 5th design principle is service orientation and planning. How many times do we get calls from customers wanting to know where things are? Being able to see that information real time and to be able to manage the customer experience is quite important. And then finally, modularity. So not only can you do as much or as little as you want, you can be strategic about the functions of MES and how they relate to your specific factory. I want to take this opportunity to open up the questions session of this, and to make sure that we're going to get to the kinds of questions that you have for this. There's a number of them, so bear with me as I try to get through, but we want to get your feedback, your questions, and give you the kinds of answers that you might need. One of the questions is, related to cabinet vision. So yes, the answer is it is possible to be able to work with existing data. Not only do we have established links with cabinet vision, but also with CADCAM, or CADCAM technology from HOMAG eSolutions, as well as MES Software. So while you may be considering changing your CAD/CAM engineering software, you don't have to be able to harness the information and to be able to implement MES. What is the implement? How long does it take to implement? I think we all know that there are some systems that can take a great amount of time or effort to be able to implement into use. In some cases, things like ERP can be upwards of a year or more. Even engineering solutions can be many weeks or even months to be able to implement. In the strategy of this MES system, because it's using data from your engineering solution, the implementation time can be very small. I don't want to give a precise one-size-fits-all, because obviously there can be strategies for data enhancement, number of systems, and those kinds of things. But an average implementation is between 2 and 3 days. So this is a technology that, if you decide to implement, can happen very quickly and begin to give you almost immediate reward or benefit from the system right out of the gate. Cost. Well, this is really meant to be more of an educational time, but I think I can at least give you some basics for this. Again, not a one-size-fits-all, but it's possible to even be able to implement this technology, at starting at a $10,000 range, including implementation and training of it. Some companies are going to want more users, more stations to be able to utilize some of the great benefits for it, but it's not a significantly expensive investment to be able to get started with that. How does the visualization work? Okay, so when WebCab is importing data from these technologies, a CAD/CAM, a cabinet vision, a microvol, not only is it bringing across the products, not only is it bringing across the parts, but it's reading the actual database to know the part's position, orientation, rotation, and geometry. So what you're seeing on screen is not something that's having to be created by those CAD/CAM systems, but something that is being read from the database and rendered immediately. So realistically, wherever you have a visualization station, it means that someone, by simply scanning a part label, can see the precise image of that part, more details about it, the product it's associated to, being able to hide any parts or pieces like doors or shelves or whatever that you want to drill down to it, and the associated hardware of that product. So an incredibly valuable thing. It says, can you elaborate on what would be required for computer integration? I'm concerned about the ability to communicate into a system from several stations throughout the shop. And so there is definitely, Kevin, a need to do an evaluation based on each company's needs and how these systems need to be all wired and communicating together. So we would be expecting that wherever there are collection stations that do not have the HOMAG Power Touch control, that you have a computer that is hooked to the server in the office so that communication can happen generally from that computer. Then there are like wireless barcode scanners that can work with each of the computer station. But if you have interest in learning more about the strategy for what specific stations that you might want and how you want to collect in your shop, we can certainly help you with that. For some companies, they may only want to do tracking, maybe at the first operation, at prior to assembly, at shipping. It may only be a few stations. In other cases, there may be need for things like tracking, visualization, or other MES purposes at a number of stations. Yeah, so it's asking about the recommended internet service requirement for connectivity to WebCAB. If we think about what we're doing here, this is intranet instead of internet at this case. If we were talking about technology where we were doing point of sales out to the web and those kinds of things, that it would be quite different, but we're dealing with the internal information. It says, Jonathan, I'm going to give you this one. It says, how often does our internal server database connect back to the WebCAD system? I believe that this is real-time information, and so would you like to elaborate on that?
Yeah, it is real-time information. So what's happening is that you have a database installed on your server, and the system just goes in and reads the information at the moment that it needs to get the information and send back when there's a status change on SQL Express server that we use.
Exactly. A question came up. This one's a little bit off of this, but it says, can CAD/CAM be integrated with an ERP system? The answer is yes to that. As a matter of fact, in the OpenSQL database, we even have a denormalized table so that information becomes constant, even with software updates or data changes, so that the link or communication to ERP can work. And again, as Jonathan mentioned, and I tried to re-emphasize, that this MES technology is already linked and integrated with industry common design engineering CAD/CAM platforms such as CADCAM, Cabinet Vision, and Microvellum. Question says, with regard to MES, does WebCAD consult optimize machinery and equipment flow as well, or is WebCAD purely software-based? And so this is not doing capacity planning. And an element of capacity planning is not only recognizing the capacity of the floor, but routings and alternative routings. And so that would be primarily a function, James, of ERP for it to do the optimization of the equipment flow as well. What it does allow you to do, as we mentioned, is to enhance the data coming from your existing CAD/CAMs that might not even understand about the routing or sorting through your floor. So hopefully that answers that question as well. Yeah. So question about systems requirements and stuff. I will be glad to provide out anybody that's interested in that specific information. We can certainly provide that related to PC, to the kinds of devices that you might have on the shop floor, whether it be touchscreen monitors, scanners, printers, those kinds of things. So if you let us know, we can certainly say that that's the case. It says, is it safe to assume that at a given station, each part would need to be scanned as it's processed? No, actually, most of our customers don't want to do that. For example, if there was a work order going to the shop floor, often what people might want to do is to give an indication that the start of a work order happened at a particular station. So one scan lets us know that we're in process for that, and another scan can change the status to completed at that station. So without needing to scan each and every individual part within this, we can know the production progress. Obviously, when we're only scanning first and last, we only know that it's begun and when it's done, instead of knowing the exact count of all the parts, but most people believe or recognize that there's only certain times or stations that you might want to go to the effort to scan each part. Let me give you an example of one. At what we would consider to be an inspection station, maybe this is right before assembly to where someone is catching parts and they are scanning a part barcode to signify that the part is good or damaged, and putting it in the right slot so that assembly can easily recognize which products to begin to assemble because all of the parts and pieces are there. Then it probably becomes more important, at least for some shops, to be scanning each of the parts for their individual status. Otherwise, the production order can just be flowing through with a start scan and a finish scan. How would you know that if there is a part lost in process? Each company probably has their own strategy for what is happening, but as I just described, many companies want to have an inspection or pre-assembly station to where you are scanning all of the parts, the part labels, so that assembly doesn't begin until they're all available. And obviously, if we've made it through a number of scans and products are going, it's going to become obvious that there is one missing and which one is missing, so that we can make the best real-time information about whether to consider that part to be marked for back order and shipped separately, or to be expedited back through manufacturing and catch up with the assembly. We recognize, just by a number of the things, we recognize that in a webcast session, we surely can't get to every individual thing. The point was to be educational, to help us understand what Industry 4.0 is and how its design principles are influencing MES applications, and so how you can begin to be making decisions. I heard it said recently, and this is just a repeat, basically, it's not always practical to retool an entire factory with all the latest and greatest equipment and controllers, such as the HOMAG Power Touch Control, but we certainly can be considering the influence of Industry 4.0 in our decisions here forward. So maybe on the agenda is an MES system, or maybe it's an edge band or a case clamp or whatever it is. We may not have every single piece of equipment in our factory able to do automated and instant feedback or that kind of application, but if as we're retooling, as we're choosing software applications, whether it's point of sale, CADCAM, optimization, nesting, MES, whatever it is, we can be making sure that the decisions that we're making are following along with the design principles of Industry 4.0. For sure, we don't want to be stuck in Industry 3.0 by the time that Industry 5.0 comes. It was only 40 years between the third and the fourth industrial revolution, almost half the time as it was before, where it was 70% of the time. So if indeed that is increasing again, we're going to be moving towards the fifth industrial revolution probably in less than 20 years, if that continues to hold true. So making those decisions today, following the principles of Industry 4.0, are probably smart factory type decisions. I think that we got to most of the ones that are not just individual company kinds of questions. Again, a pricing question. So instead of talking about numbers, we might consider that there might be a number of office users. For example, maybe someone who's involved in planning, importation of projects, someone who's managing part alerts, those kinds of things. Then on the shop floor, it really becomes up to you, and we'll be glad to help and consult on where it is that you might want to have feedback stations or visualization. And I believe that that will be different for different companies. Some may want to start with very basics, as I described, where you might want to be doing tracking at a first operation, maybe at inspection before assembly, or at shipping. Maybe you need a kitting station. Maybe you want one or two visualization stations. It's completely up to you. So it's the number of users in the office plus the number of stations on the shop floor is the basic way that would accumulate to being able to quote the software portion of this package. Again, it's not very expensive compared to what it can do for your business. I believe that if we thought back at all the questions that we asked early on, how much does it cost if the software probably has a return on investment of a very, very short amount of time. It says, so to be clear, this system is integrated into CADCAM. It is not an additional software package. It is separate software from CADCAM. This is a MES software that can link to the output of CADCAM or other CAD/CAM software. So you could have CAD/CAM without this. You could have this without CAD/CAM. But to use this software practically, it does mean that it makes sense for you to have some kind of a centralized database, a CAD/CAM or engineering system, so that it can link to that. It says, when we purchase the version of CAD/CAM you quoted, will this software come with it? No, it is nothing to do with CAD/CAM. This is MES software, so we think of CAD/CAM as design, engineering, manufacturing software. This is MES, so manufacturing execution software. It just happens that one of the links to this software happens to be CAD/CAM. So if you want to consider this MES functionality, we would need to come together and to discuss the numbers of users and stations to be able to come out with a commercial quote on that. Okay, we already have CAD/CAM in operation, so we would be good to go with an MES system. Yes, that would be correct. If you already have CAD/CAM in operation running, we would be able to link directly to that. So in a very short amount of time, you would be able to do these MES functions. So this is a there's some questions about connecting then on the backside to other systems. This is a database system, so it is possible to output, if we're thinking to other ERP or those kinds of things, it would be possible to take the data that has come from this. Question also about accounting. Yes, in theory, this could connect to QuickBooks or other accounting programs. We should do a consultation to be thinking about what information it is that we want to pass from one system to another, but it is an open architecture database system, so it can, in theory, be connected to other systems as well. The links for Microvellum system that was 6.7 to where access an MDB file. We also have links to the versions of that which are using the SQL data, so we can link to either one of those as well. Okay, I think that gets us through most of the questions. I want Jonathan to thank you again for your time today and for helping us understand more about your technology. Your presentation was great. And then secondly, I want to thank you for taking the time to attend today's webcast. I hope and trust that it was a good investment of your time. We appreciate you considering the technologies that were presented today, and we hope that from an educational standpoint that you picked up something that would be valuable to your business. Once again, thank you all so much. This ends today's webcast. Take care and God bless.